Hey everyone! Tonight we're going to explore something both profound and deeply peaceful. The end of time itself. Not in some dramatic, apocalyptic sense, but in the quiet, gentle way that the universe actually works. So settle in, maybe dim the lights, and let's drift together through the deepest questions about time, space, and what it all means when everything finally comes to rest. Before we begin this journey, take a moment to get comfortable. This isn't a story about sudden endings or cosmic catastrophes. It's about the slow, inevitable, and strangely beautiful way that time itself might one day fade away. The universe doesn't end with explosions or collisions. It ends with silence, stillness, and a kind of eternal peace that's both humbling and oddly comforting. Now, when we talk about the end of the universe, we're really talking about theoretical models. These are our best scientific guesses based on what we know about physics, thermodynamics, and the way energy moves through space. Nothing is certain. The universe is vast and mysterious, and it still holds secrets we haven't uncovered. But these models give us a glimpse into possibilities, into what might happen when all the stars have burned out and all the energy has spread thin across an infinite expanse. What we're exploring tonight isn't science fiction. It's science itself, the careful work of physicists and cosmologists who've spent lifetimes thinking about entropy, gravity, and the nature of time. Their conclusions are gentle, almost meditative in their own way. The universe, they suggest, doesn't race toward destruction. It drifts toward equilibrium, toward a state where everything is perfectly balanced and perfectly still. To understand what happens to time at the end of everything, we first need to understand what time actually is. This might seem obvious, but time in physics is far stranger and more beautiful than our everyday experience suggests. Time isn't just the ticking of clocks or the turning of calendar pages. It's woven into the very fabric of space itself, stretching and bending with gravity, flowing differently depending on where you are and how fast you're moving. Einstein showed us that time is relative. A clock on Earth ticks differently than a clock on a speeding spaceship. A watch near a massive star runs slower than one floating in empty space. Time dilates, stretches, and contracts based on the curvature of space-time around it. This isn't just theory anymore. We've measured it with atomic clocks, seen it in GPS satellites, and watched it play out in the light from distant galaxies. When astronomers look at quasars from the early universe, they see time moving 5 times slower than it does for us here on Earth. The expansion of the universe itself creates this effect. Events that happened billions of years ago appear to unfold in slow motion from our perspective, like watching a movie played at quarter speed. Time itself has been evolving since the Big Bang, and it will continue to evolve as the universe expands and cools. But time is also tied to something even more fundamental, something called entropy. Entropy is a measure of disorder, of how spread out energy becomes in any system. The second law of thermodynamics tells us that entropy always increases. Heat flows from hot objects to cold ones. Energy disperses. Order breaks down into chaos, and that chaos spreads until everything reaches the same temperature, the same level of energy. This is where the story of time's end begins. Not with a bang, but with the slow, inevitable spreading of energy across an ever-expanding universe. Right now, the cosmos is full of energy gradients. Stars burn hot while space remains cold. Galaxies swirl with motion while vast regions sit nearly empty. These differences drive change, and change gives time its meaning. Think about it this way. If you have a cup of hot coffee and you leave it on your desk, it slowly cools down to room temperature. Once it reaches that equilibrium, nothing more happens. The coffee doesn't spontaneously heat up again. It doesn't cool below room temperature. It just sits there, perfectly balanced with its environment. In a sense, Time stops having meaning for that cup of coffee because nothing interesting happens to it anymore. The universe faces the same fate, but on an unimaginably grander scale. Stars will burn out. Galaxies will drift apart. Black holes will evaporate. And eventually, if current models are correct, everything will reach the same temperature, the same energy level. When that happens, there will be no more gradients to drive change, no more processes to mark the passage of time. This scenario is called heat death, though the name is misleading. It's not a violent end. It's more like the universe falling asleep, drifting into a state of perfect rest where nothing disturbs the cosmic quiet. Heat death represents maximum entropy, the point where energy is distributed as evenly as possible across space. Scientists estimate this could happen in about 10 to the power of 100 years from now. That's a 1 followed by 100 zeros, a number so vast it defies comprehension. To put it in perspective, the universe is currently only about 14 billion years old. The heat death timeline is trillions upon trillions of times longer than the entire history of everything we know. Long before heat death arrives, the universe will pass through several distinct eras. We're currently in what cosmologists call the stelliferous era, the age of stars. For the next trillion years or so, stars will continue forming from clouds of gas and dust. They'll burn bright, live their lives, and die in spectacular explosions or quiet fades depending on their mass. But even this stellar paradise has limits. The universe contains only a finite amount of hydrogen and helium, the raw materials for star formation. As more and more of this gas gets locked up in stellar remnants, white dwarfs, neutron stars, and black holes, fewer new stars will be born. Eventually, perhaps in 100 trillion years, the last star will flicker to life, burn through its fuel, and die. What follows is the degenerate era, a time when the universe will be populated by the corpses of stars. White dwarfs will slowly cool over trillions of years, radiating their heat into space until they become cold, dark objects called black dwarfs. Brown dwarfs, stars that never quite ignited, will drift through space like cosmic embers. Planets will continue orbiting these stellar remnants, but they'll be frozen worlds in a universe growing ever darker and colder. Even in this seemingly lifeless era, time will continue to have meaning, because things will still be happening, just very slowly. White dwarfs will cool. Planets will gradually spiral into their dead stars due to gravitational wave radiation. And in the far future, quantum mechanical processes will allow even the most stable matter to slowly transform. This is where the story becomes truly mind-bending. On timescales of 10 to the power of 1500 years, quantum tunneling will allow the atoms in stellar remnants to rearrange themselves. Every white dwarf, every cold planet, every chunk of rock floating in space will slowly convert into pure iron through this process. It's like the universe is performing incredibly slow alchemy, transforming all matter into the most stable configuration possible. Quantum tunneling is one of those beautiful quantum mechanical phenomena that allows particles to do things that seem impossible. Imagine throwing a ball at a wall. Classically, the ball should bounce back every time, but quantum mechanics tells us there's a tiny probability that the ball could pass right through the wall, appearing on the other side as if the wall didn't exist. This probability is incredibly small for everyday objects, but given enough time, even the most unlikely quantum events become inevitable. In stellar remnants cooled to near absolute zero, quantum tunneling allows atomic nuclei to fuse even without the extreme temperatures and pressures found in stellar cores. It's an impossibly slow process, but time itself seems infinite from this perspective. Over unimaginable eons, all matter will settle into the most stable nuclear configuration, creating spheres of pure iron floating in the void. But even iron isn't forever. If protons, the building blocks of atomic nuclei, are unstable on extremely long timescales, then even iron will eventually decay. Some theoretical models suggest protons have a half-life of about 10 to the power of 34 years. If this is true, then in the far future, all atomic matter will simply disintegrate, leaving behind only electrons, positrons, neutrinos, and photons. The evidence for proton decay remains elusive. Despite decades of careful experiments, scientists have never observed a proton spontaneously breaking apart. But the theoretical framework of grand unified theories suggests it should happen eventually. Whether protons are truly stable or just incredibly long-lived remains one of the great unanswered questions in physics. If protons do decay, the universe will enter an era dominated by leptons and photons. Electrons and positrons will occasionally find each other and annihilate, releasing energy in the form of gamma rays. These photons will continue traveling through space, their wavelengths stretching as the universe expands, growing redder and redder until they become radio waves, then longer and longer wavelengths, carrying less and less energy. Throughout all these transformations, black holes will persist as the universe's most enduring structures. But even black holes aren't eternal. Stephen Hawking showed that they emit radiation due to quantum effects near their event horizons. This Hawking radiation causes black holes to slowly evaporate, losing mass and energy to space. The evaporation process is incredibly slow for large black holes. A black hole with the mass of our Sun would take about 10 to the power of 67 years to completely evaporate. Supermassive black holes, the giants that lurk at the centers of galaxies, could persist for 10 to the power of 100 years or more. But eventually, even these cosmic monsters will fade away, releasing their mass energy back to the universe in the form of elementary particles and radiation. The final moments of black hole evaporation are particularly interesting. As a black hole loses mass, its temperature actually increases. The process accelerates, with the black hole radiating faster and faster until it finally explodes in a brief flash of gamma rays. These final instants occur on timescales approaching the Planck time, the smallest meaningful unit of temporal measurement in physics. What emerges from black hole evaporation is a gas of elementary particles and photons, all at nearly the same temperature as the cosmic background radiation. This represents the closest the universe can come to perfect thermodynamic equilibrium, the heat-death state, where entropy reaches its maximum value. But here's where the story becomes beautifully subtle. Even in heat death, even when the universe has reached maximum entropy, time itself doesn't necessarily stop. The equations of general relativity still apply. Space-time continues to exist, continues to expand, continues to provide a framework within which events could theoretically occur. What stops is change. In a universe at thermodynamic equilibrium, there are no energy gradients to drive processes forward. No heat flows from one region to another because everywhere is at the same temperature. No chemical reactions occur because there's no free energy to power them. No life exists because life requires energy gradients to maintain its complex structures. From one perspective, this is the end of time as we know it. Time as experience change, as the unfolding of events, as the arena in which interesting things happen. Without processes to mark its passage, without change to give it meaning, experiential time fades into irrelevance, even though coordinate time continues ticking forward. But this raises profound questions about the nature of time itself. Is time purely physical, defined by the geometry of space-time? Or is it experiential, meaningful only when change occurs? These questions touch the deepest foundations of physics and philosophy, and they remain beautifully unresolved. Some physicists suggest that even in heat death, quantum fluctuations could still occur. The vacuum of space is never perfectly empty. It seethes with virtual particles that pop into existence and disappear almost instantly. In a universe at maximum entropy, these fluctuations might be the only remaining source of change, the final heartbeat of time itself. Others propose that the universe might not reach perfect equilibrium at all. Perhaps new physics, currently unknown to us, will intervene. Perhaps dark energy, the mysterious force driving cosmic acceleration, will continue to stretch space faster and faster, eventually tearing apart the fabric of space-time itself in a scenario called the Big Rip. In the Big Rip model, the expansion of space accelerates until it overcomes all fundamental forces. First, galaxies separate beyond the cosmic horizon. Then solar systems are torn apart. Eventually, even atoms are ripped apart as space expands faster than light can travel between an electron and its nucleus. This scenario would end not in cold equilibrium, but in the violent dissolution of spacetime itself. Another possibility involves vacuum decay, the idea that our universe might exist in a false vacuum state, a configuration that appears stable but isn't actually the lowest possible energy state. If the universe could tunnel to a lower energy configuration, it would release enormous amounts of energy and potentially change the fundamental constants of nature. Such a phase transition would propagate outward at the speed of light, rewriting the laws of physics as it goes. But these dramatic scenarios remain speculative. The gentle drift toward heat death seems most consistent with our current understanding of physics. It's a scenario that speaks to something profound about the nature of existence itself, the idea that all things tend toward rest, toward equilibrium, toward a state of perfect stillness. And there's something oddly comforting about this vision. The universe doesn't end in violence or catastrophe. It simply grows quiet. Stars fade one by one. Galaxies drift apart into the darkness. Black holes evaporate into whispers of radiation. And finally, everything settles into a state of perfect calm, like a vast ocean without waves, stretching infinitely in all directions. In this cosmic twilight, time becomes something different than what we know today. It's no longer the driving force of change and evolution. Instead, it becomes pure duration, the simple fact of existence extending forward without event or incident. It's time without story, without drama, without the constant urgency of things happening and changing. Perhaps this is the most profound lesson about time's end. It shows us that time itself isn't fundamental. What we really value, what gives our existence meaning, are the patterns and processes that unfold within time. The relationships we build, the experiences we gather, the ways we change and grow and connect with others. When the universe finally reaches its state of maximum entropy, when all the stars have burned out and all the black holes have evaporated, when space itself stretches cold and empty in every direction, time will still exist in some abstract sense, but it will be time without content, duration without event, existence without experience. And in that ultimate stillness, in that perfect quiet that awaits the cosmos, there might be a kind of peace that we can barely imagine. The restless urgency of entropy increase will finally be satisfied. The universe will have reached its destination, the state toward which it has been slowly drifting since the moment of the Big Bang. This is where our journey through cosmic time leads us, not to destruction, but to rest, not to ending, but to completion. The universe will finally be at peace with itself, having explored every possibility, having burned through every gradient, having settled into the deepest possible state of equilibrium. And while this might seem like an ending, it's really more like a resolution. The cosmic story will have been told in full, every chapter written, every possibility explored. What remains is not nothing, but everything, frozen in a state of perfect balance, existing in a timeless moment that stretches forward into infinity. In the end, time doesn't disappear. It simply becomes still, like the surface of a deep lake on a windless night, reflecting the universe back to itself in perfect, eternal silence. But what does it actually mean for time to become still? This question takes us deeper into the heart of physics, into territories where our everyday intuition begins to break down and something more profound emerges. The relationship between time and change isn't just philosophical speculation. It's embedded in the very mathematics that describe our universe. When physicists talk about time, they distinguish between two different concepts that often get confused in everyday conversation. There's coordinate time, which is the time measured by clocks and calendars, the steady tick that marks moments in space-time. And then there's proper time, which is the time actually experienced by any particular observer, the time that flows differently depending on gravity and motion. In our current universe, these two types of time usually align fairly well for most practical purposes. Your wristwatch ticks at nearly the same rate, whether you're sitting in a chair or walking down the street. But as we've seen, this isn't always the case. Near massive objects or at high velocities, proper time begins to diverge dramatically from coordinate time. As the universe evolves toward heat death, this distinction becomes increasingly important. Even when all the stars have burned out and all the black holes have evaporated, coordinate time will continue its steady march forward. The mathematical framework of space-time will persist, providing a stage on which events could theoretically unfold. But without energy gradients to drive change, without processes to create distinguishable moments, proper time, experiential time, gradually loses its meaning. It's like having a perfectly functioning clock in a room where nothing ever happens. The clock continues ticking, marking seconds and minutes and hours, but those measurements become abstract, disconnected from any actual experience or change. Time becomes pure mathematics rather than lived reality. This transformation happens gradually across cosmic history. Even now, in different parts of the universe, time flows at different rates. In the intense gravitational field near a black hole, time dilates so severely that what seems like minutes to someone falling past the event horizon would appear as eons to a distant observer. The falling observer experiences time normally from their perspective, but to the rest of the universe, they seem frozen at the edge of the black hole, their image slowly fading and red-shifting into invisibility. These extreme examples help us understand what might happen on cosmic scales. As the universe expands and cools, as matter becomes more and more dilute, the very fabric of space-time stretches and relaxes. The intense curvature around massive objects gradually flattens out. The universe becomes more and more geometrically simple, approaching what physicists call Minkowski spacetime, the flat, uncurved background that Einstein used as his starting point. In this flattened cosmos, coordinate time continues flowing at its steady rate, but there's less and less to mark its passage. Without stars forming and dying, without galaxies colliding and merging, without the complex dance of matter and energy that currently defines cosmic evolution, time becomes something closer to pure duration. But even duration requires something to endure. And this brings us to one of the most subtle questions in all of physics. What exactly persists in a universe that has reached maximum entropy? What remains when all the interesting processes have ground to a halt? The answer depends partly on which theoretical model proves correct. If protons are truly stable, then even in heat death, the universe will contain vast numbers of electrons, protons, and neutrons, along with photons and perhaps neutrinos. These particles will be spread incredibly thin across space, so dilute that any two particles might be separated by distances larger than our current observable universe. They'll drift through space at temperatures just barely above absolute zero, rarely interacting, rarely changing. In such a universe, time would still have some meaning because these particles continue to exist, continue to move through space, continue to carry information about their past. A proton formed in the early universe would still bear the quantum mechanical signature of its creation, even billions upon billions of years after the last star has died. But if protons decay, as some theories suggest they must, then even this minimal structure disappears. All atomic matter eventually breaks down into leptons and photons. Electrons and positrons occasionally find each other across the vast emptiness and annihilate, producing brief flashes of gamma radiation that quickly redshift into radio waves and beyond. In this scenario, the universe becomes an incredibly dilute gas of photons and perhaps neutrinos, all at essentially the same temperature. These particles still move through space, still carry energy and momentum, but they interact so rarely that for practical purposes, each photon travels alone through infinity, carrying its quantum information forward through time without ever encountering another particle. And yet, even in this most minimal possible universe, something profound persists. Information. Every particle, no matter how isolated, carries within its quantum state a complete record of its history. The wavelength of a photon, its polarization, its direction of travel, all encode information about where it came from and what processes created it. This is where the intersection of time and information becomes beautifully mysterious. Information, according to the fundamental principles of quantum mechanics, cannot be destroyed. It can be scrambled, encoded in complex ways, spread across vast regions of space, but it cannot simply vanish. Even when black holes evaporate through Hawking radiation, most physicists believe the information that fell into them must somehow be preserved in the outgoing radiation, though exactly how this happens remains one of the deepest puzzles in theoretical physics. If information truly is conserved, then even in the far future, even in a universe that appears completely empty and uniform, a complete record of everything that ever happened still exists, encoded in the quantum correlations between particles separated by cosmic distances. The formation of the first stars, the evolution of galaxies, the brief flicker of life on countless worlds, all of it preserved forever in the quantum information carried by photons wandering through the void. This preservation of information suggests something profound about the nature of time itself. Even when the universe appears to have forgotten its past, when all structure has dissolved and all processes have ceased, the past persists as information. Time doesn't just flow forward, creating moments that then disappear. Every moment leaves an indelible mark on the quantum state of the universe, a signature that can never be completely erased. From this perspective, the heat death of the universe isn't really a death at all. It's more like a vast library where all the books have been written and shelved, where every story has been told and every possibility explored. The library grows quiet, the reading stops, but the knowledge remains, preserved in a form more permanent than any physical structure. But information without a reader, without some process to decode and interpret it, raises its own philosophical questions. What does it mean for the universe to remember its past if there's no consciousness left to access those memories? What value does preserved information have in a cosmos where no mind exists to contemplate it? These questions push us toward the very edges of what physics can tell us. Science excels at describing how things work, at predicting what will happen under specific conditions, at revealing the mathematical relationships that govern natural phenomena. But when we ask about meaning, about value, about the deeper significance of existence itself, we enter territory where physics and philosophy begin to merge. Some physicists have suggested that consciousness itself might be more fundamental than we typically assume. Perhaps the universe's ability to know itself through conscious observers isn't just a lucky accident, but a fundamental feature of reality. In this view, the preservation of information in the far future might ensure that consciousness could theoretically re-emerge, that the universe might eventually wake up from its long sleep and remember everything that came before. Other theories propose that our universe might not be alone, that it might be one of countless universes in an infinite multiverse where every possible quantum outcome is realized somewhere. In such a cosmos, Even as our particular universe fades into heat death, countless other universes continue evolving, continue generating new stars and galaxies and possibilities. But these ideas, fascinating as they are, remain largely speculative. What we can say with more confidence is that the universe we observe today is remarkably rich and complex, filled with structures and processes that seem almost miraculous in their intricacy and beauty. The fact that matter organized itself into stars and planets, and ultimately into conscious beings capable of contemplating their own existence, is perhaps the most extraordinary thing we know. And this brings us to a deeper appreciation of time itself. Time isn't just the medium in which change occurs, it's the dimension that allows for the gradual unfolding of complexity, the slow evolution from simplicity to richness, to consciousness, and back towards simplicity again. Without time, there would be no stories, no development, no possibility for the universe to explore its own potential. The cosmic story that unfolds over billions and trillions of years is ultimately a story about time's creative power. In the beginning, shortly after the Big Bang, the universe was remarkably simple and uniform. Tiny quantum fluctuations in an otherwise smooth background of hot, dense energy provided the only variation. But time allowed those fluctuations to grow, to amplify, to eventually become the seeds from which all cosmic structure emerged. Over millions of years, gravity pulled matter together into the first stars. Those stars lived and died, enriching space with heavy elements. Subsequent generations of stars formed planetary systems where chemistry could become complex, where molecules could organize into patterns of stunning intricacy. And on at least one planet, perhaps on many, those patterns became self-replicating, self-modifying, eventually self-aware. This entire progression, from quantum fluctuations to conscious beings, required time not just as a passive backdrop, but as an active participant. Each stage built upon the previous one, each level of complexity emerging from and depending upon what came before. Time provided the continuity that allowed causes to have effects, that allowed the universe to learn from its own experiments and build ever more sophisticated structures. But time's creative phase appears to be temporary. The same thermodynamic principles that allowed complexity to emerge also ensure that it will eventually fade away. The energy gradients that power stars and drive chemical reactions and sustain life are gradually being exhausted. The universe is slowly spending its inheritance of free energy, moving inexorably toward a state where no further work can be done. This doesn't diminish the magnificence of what has already been accomplished. If anything, it makes the current era more precious, more remarkable. We live in a brief golden age of cosmic history, a time when the universe is neither too young to have developed interesting structures, nor too old to sustain them. We exist in the narrow window when stars shine and planets orbit, and life can flourish, and consciousness can emerge to contemplate its own existence. The knowledge that this golden age won't last forever might seem melancholy, but it also highlights the extraordinary nature of our present moment. Against the vast background of cosmic time, the era of complexity and consciousness is remarkably brief. And within that brief era, the existence of any individual star or planet or living being is briefer still. Yet this brevity doesn't make these phenomena less real or less significant. A star that burns for 10 billion years is no less magnificent for eventually running out of fuel. A planet that harbors life for 1 billion years creates real beauty and meaning during its active period. A conscious being that exists for decades or centuries participates fully in the universe's ongoing exploration of its own possibilities. This perspective suggests a different way of thinking about time's end. Rather than focusing on what will be lost, we can appreciate what is being preserved. Every moment of cosmic history, every structure that forms, and every process that unfolds contributes to the universe's growing understanding of itself. Each star that lives and dies adds to the cosmic story. Each planet that forms explores new possibilities for matter to organize itself. Each conscious being that emerges represents the universe becoming aware of its own existence. Even as these structures eventually fade away, their contributions to the cosmic story remain permanently encoded in the universe's quantum information. The heat death of the universe doesn't erase this history. It preserves it in the most fundamental way possible, as patterns of correlation that can never be destroyed, only transformed. From this view, the end of time becomes less about loss and more about completion. The universe will have finished telling its story, will have explored all the possibilities available to it given its initial conditions and physical laws. What emerges isn't emptiness, but fullness, not absence, but presence in its most essential form. The mathematical structure of space-time will persist, providing an eternal framework within which the universe's complete history exists as a finished work of art. Every moment that ever occurred will continue to exist within this structure, not as memory or record, but as fundamental reality. Past, present, and future become equally real, equally permanent, equally significant. This is perhaps the most profound insight about time's ultimate fate. Time doesn't disappear or get destroyed when the universe reaches heat death. Instead, time reveals its true nature as something more fundamental than process or change. Time, in its deepest sense, is the dimension that allows existence itself, the framework within which everything that is can be. When all the clocks have stopped and all the processes have ceased, when the universe has settled into its final state of maximum entropy, time itself will remain as the eternal foundation of reality. Not time as duration or flow, but time as the basic structure that makes existence possible at all. And in that ultimate stillness, in that perfect quiet that represents the completion of the cosmic story, there might be a peace more profound than anything we can currently imagine. The universe will have achieved perfect rest, perfect balance, perfect fulfillment of its deepest nature. Every possibility will have been explored, every potential realized, every story told to its conclusion. This is where our journey through cosmic time ultimately leads us. Not to an ending in any ordinary sense, but to a kind of eternal present, where everything that ever was continues to be, preserved forever in the mathematical structure of space-time itself. The universe doesn't die. It simply finishes growing and settles into its final, perfect form. And perhaps that's the most comforting insight of all. In a cosmos where time itself becomes still, where change gives way to eternal being, nothing is ever truly lost. Every moment of beauty, every spark of consciousness, every act of love and creation becomes part of the universe's permanent nature, written into the very fabric of reality itself. Time, in the end, doesn't disappear. It simply comes home to itself, revealing its true nature as the eternal foundation upon which all existence rests. And in that revelation, in that final stillness, the universe achieves a kind of peace that transcends anything we might ordinarily call an ending. The cosmos doesn't conclude its story with drama or catastrophe. Instead, it drifts gently into a state of perfect completion, where time itself becomes the quiet, eternal witness to everything that ever was, is, or could be. And in that witness, in that perfect stillness, the universe finds its deepest rest. Est-rest.ness. The universe finds its deep, but there's another layer to this cosmic story, one that takes us even deeper into the mystery of what time really means. As we drift through these vast cosmic epochs, something subtle but profound happens to the very fabric of space-time itself. The universe doesn't just change its contents as it evolves toward heat death. The stage on which all cosmic drama unfolds begins to transform as well. Right now, in our current cosmic era, space-time is richly textured, full of curves and valleys created by massive objects. Every star, every planet, every black hole warps the fabric of space and time around itself. These gravitational wells create the complex geometry that Einstein described, where time flows differently depending on where you are and how deep you've fallen into gravity's embrace. But as the universe continues to expand and cool, as matter becomes ever more dilute and spread thin across vast distances, this rich tapestry of curved space-time gradually flattens out. The massive objects that currently create dramatic warps in the fabric of reality slowly lose their gravitational influence over cosmic-scale regions. Black holes evaporate. Stellar remnants drift apart. The universe becomes geometrically simpler, approaching what physicists call a flat, empty space-time. This flattening process happens so slowly that it's almost impossible to visualize on human timescales. Imagine a trampoline that's been weighted down with bowling balls, creating deep depressions and curves across its surface. Now imagine those bowling balls slowly dissolving away, grain by grain, over trillions of years. As each ball disappears, the trampoline gradually returns to its natural flat state. The curves smooth out, the complex geometry simplifies. What remains is a perfectly flat surface stretching endlessly in all directions. This is roughly what happens to space-time itself as the universe evolves toward heat death. The gravitational sources that currently create time dilation and spatial curvature slowly fade away. Without massive objects to bend space-time, the universe approaches what's called Minkowski spacetime, the flat, uncurved background that forms the foundation of special relativity. In this flattened cosmos, coordinate time flows uniformly everywhere. There are no longer regions where time moves faster or slower relative to distant observers. The complex relativistic effects that currently make time such a rich and varied phenomenon gradually disappear. Time becomes more like the simple, universal flow that Newton once imagined, ticking steadily forward at the same rate throughout the universe. But here's where the story becomes beautifully paradoxical. Just as time becomes mathematically simpler and more uniform, it also becomes experientially meaningless. The very flatness that makes coordinate time universal also eliminates the processes and changes that give time its significance for any potential observer. Think about what makes time meaningful in our current universe. It's the differences, the gradients, the changes that mark one moment as distinct from another. The birth of a star creates a new source of light and heat. The collision of galaxies reshapes entire regions of space. The formation of planets provides new environments where chemistry can become complex. These events create distinguishable moments, markers that allow us to say this happened before that. This moment differs from that one. But in a universe approaching maximum entropy, these distinguishing events become rarer and rarer. Stars stop forming. Galaxies drift beyond each other's gravitational influence. Chemical reactions cease for lack of free energy. The universe settles into a state where one moment becomes essentially indistinguishable from the next. This transition from complex, curved spacetime to flat, empty spacetime represents one of the most profound transformations imaginable. It's not just that the contents of the universe change. The very nature of space and time themselves evolve from rich, dynamic entities full of structure and variation to simple, uniform dimensions where nothing interesting can happen. Yet even in this transformation, something beautiful emerges. The simplification of space-time doesn't destroy its fundamental nature. If anything, it reveals the deeper mathematical structure that underlies all of reality. Beneath all the complex curvature and time dilation effects of our current universe lies a simple, elegant framework, the basic architecture of space-time itself. This framework persists even when all the matter and energy that currently give it structure have dispersed into uniform background radiation. Space-time continues to provide the stage on which existence unfolds, even when that stage becomes empty and still. The mathematical relationships that Einstein discovered, the geometric principles that govern how space and time relate to matter and energy, all remain perfectly valid in a heat-death universe. In some sense, this represents space-time returning to its most natural state. All the warps and curves and complex geometries we see today are deviations from the flat, simple background that forms space-time's default configuration. As the universe evolves toward heat death, space-time gradually relaxes back into this natural state, like a piece of elastic returning to its original shape after being stretched and twisted. This relaxation process reveals something profound about the relationship between time and change. In our current universe, time and change seem inextricably linked. We measure time by observing changes, counting oscillations of atoms, tracking the motion of planets, noting the decay of radioactive elements. Time appears to be the dimension in which change unfolds. But as the universe approaches heat death, this relationship becomes more subtle. Change becomes rarer and rarer, yet time itself, in the form of coordinate time, continues flowing. The mathematical dimension of time persists, even when the changes that normally mark its passage disappear. This suggests that time might be more fundamental than change. That temporal dimension exists independently of the processes that usually give it meaning. Consider what this means for our understanding of existence itself. Even in a universe where nothing happens, where no processes unfold and no events occur, the dimension of time still provides a framework for being. Space-time still curves according to Einstein's equations, even when the matter and energy terms in those equations approach zero. The stage remains, even when the performance ends. This persistence of empty space-time raises fascinating questions about the nature of existence. What does it mean for space-time to exist when it contains nothing? Is empty space-time really empty, or does it retain some subtle structure, some capacity for future change? These questions push us toward the very foundations of physics, toward the deepest principles that govern reality itself. Quantum mechanics suggests that even empty space isn't truly empty. The quantum vacuum seethes with virtual particles that pop into existence and disappear almost instantly. These quantum fluctuations represent the minimum level of activity allowed by the uncertainty principle. Even in perfect vacuum, even in the absence of all matter and radiation, these tiny fluctuations continue. In a heat-death universe, these quantum fluctuations might be the only remaining source of change, the final tick of time's clock. Virtual particles would still appear and disappear in the vacuum, creating tiny, brief deviations from perfect uniformity. These fluctuations wouldn't be observable in any practical sense, wouldn't leave lasting traces, or create new structures, but they would represent a minimal level of temporal activity, a whisper of change in an otherwise perfectly still cosmos. The timescales on which these fluctuations become significant are almost unimaginably vast. In a universe at maximum entropy, random quantum fluctuations would occasionally create small pockets of order by pure chance. Over periods of 10 to the power of 10 to the power of 50 years or more, these fluctuations might even create larger structures, perhaps even entire regions that temporarily resemble our current universe. These are called Poincaré recurrences, named after the mathematician Henri Poincaré, who showed that any finite system will eventually return arbitrarily close to its initial state if you wait long enough. In an infinite universe with finite energy density, quantum fluctuations would eventually reproduce any possible configuration of matter and energy, including configurations identical to our present cosmic epoch. This means that even in heat death, even in a universe that has reached maximum entropy and perfect thermodynamic equilibrium, Time retains the potential for surprise. Not change driven by energy gradients or physical processes, but change arising from the fundamental randomness of quantum mechanics. The universe might spend eons in perfect stillness, then suddenly, through pure quantum chance, spring back to life for brief moments before settling into quiet once again. These quantum resurrections would be incredibly rare and short-lived by any standard we can imagine. The probability of a significant fluctuation decreases exponentially with its size and complexity. Creating even a single star through quantum fluctuation would require waiting periods vastly longer than the current age of the universe. Recreating an entire galaxy would take even longer. Reproducing our current cosmic state would require timescales so vast that the numbers become meaningless. Yet the mathematical possibility remains. In an infinite future, even infinitesimally small probabilities become certainties given enough time. This suggests that time's creative power doesn't completely disappear in heat death. Instead, it transforms from a continuous process of change and evolution to an occasional random flowering of complexity arising from quantum uncertainty. This quantum perspective on time's far future offers a different vision of cosmic endings. Rather than a universe that simply winds down and stops forever, we might inhabit a cosmos that enters a phase of eternal but sporadic resurrection. Most of the time, nothing happens. The universe sits in perfect equilibrium, silent and still. But occasionally, unpredictably, quantum fluctuations create brief islands of activity in the vast ocean of stillness. From the perspective of any observer who might exist during one of these quantum resurrections, their universe would seem perfectly normal and stable. They wouldn't be aware that they live in a temporary fluctuation destined to fade back into equilibrium. To them, time would flow normally, stars would shine, planets would orbit. Life might even evolve and flourish. Only from the vastly expanded perspective of cosmic time would it become clear that these active periods are brief interludes in an otherwise quiet eternity. This vision suggests that even in heat death, time doesn't lose all its meaning. It simply changes character from a continuous river to occasional drops of rain. The river of time that currently carries us forward through cosmic evolution eventually spreads out into a vast, still lake. But even in that stillness, droplets of activity occasionally disturb the surface, creating ripples that briefly recreate the flowing time we know today. The mathematics of quantum fluctuations in heat-death spacetime is extraordinarily complex and largely speculative. We're dealing with timescales and probability distributions far beyond anything we can test experimentally. These ideas represent physics at its most theoretical, mathematical models, pushed to their logical extremes in regimes where we have no direct observational evidence. Yet there's something deeply satisfying about the possibility that time never completely loses its creative potential. Even in the deepest possible stillness, even in the most perfect equilibrium, the quantum uncertainty that lies at the heart of reality ensures that change remains possible, however rare and brief it might be. This quantum resurrection scenario also preserves something important about the nature of existence itself. If consciousness can arise through natural processes, if observers can emerge from the complex organization of matter and energy, then the same possibility exists during quantum fluctuations in the far future. The universe might occasionally become aware of itself again, might briefly wake up from its long sleep to contemplate its own existence. These future conscious beings would face the same questions we face today. They would wonder about the nature of time, the meaning of existence, the ultimate fate of their universe. They might even develop their own theories about heat death and quantum fluctuations, unaware that they themselves are living proof of time's persistent creativity. But consciousness arising from quantum fluctuations would be incredibly fragile and temporary. The same random processes that create ordered structures also destroy them. A fluctuation-born civilization would exist for a brief moment on cosmic scales before the increasing entropy reclaimed their organized matter and energy. Their thoughts, their discoveries, their art and love and wonder would flicker into existence and then fade away, leaving no trace except perhaps subtle correlations in the quantum vacuum. This fragility doesn't diminish the reality or significance of these brief moments of awareness. A conscious being that exists for even a short time experiences genuine thoughts and feelings, creates real meaning and beauty within their temporary existence. The brevity of their existence doesn't make them less real or less valuable. If anything, it makes their brief flowering more precious, more remarkable. This perspective applies to our own existence as well. We too are temporary arrangements of matter and energy in a universe evolving toward heat death. Our thoughts and feelings, our civilizations and creations, our love and art and scientific understanding are all brief fluctuations in the cosmic flow toward equilibrium. Yet this temporary nature doesn't diminish their reality or importance. They represent genuine achievements, real explorations of the universe's creative potential. The knowledge that consciousness might occasionally re-emerge in the far future, even through random quantum processes, suggests a kind of continuity that transcends individual existence. The capacity for awareness, for understanding, for appreciation of beauty and meaning appears to be written into the fundamental structure of reality itself. Even when the current manifestations of consciousness disappear, the potential for awareness remains embedded in the quantum nature of space-time. This brings us to one of the most profound questions about time's ultimate fate. What persists when everything else has faded away? What remains constant through all the cosmic changes from Big Bang to heat death to quantum resurrection? The answer seems to be the mathematical structure of reality itself. The laws of physics, the geometric relationships that govern space-time, the quantum mechanical principles that determine what's possible and what's forbidden, all these appear to transcend any particular configuration of matter and energy. They provide the eternal framework within which all cosmic evolution unfolds. Even in heat death, even in perfect thermodynamic equilibrium, these fundamental laws remain active and meaningful. Quantum mechanics still governs the behavior of virtual particles in the vacuum. General relativity still describes how space-time responds to matter and energy, even when that matter and energy are spread incredibly thin. The conservation laws still hold, ensuring that energy and momentum and electric charge remain constant even as they're redistributed across cosmic scales. This mathematical persistence suggests that what we call physical reality might be more accurately described as mathematical reality. The universe might not be made of stuff that follows mathematical rules. Instead, the universe might be mathematical rules, with what we call matter and energy being particular patterns or excitations in an underlying mathematical structure. From this perspective, the heat death of the universe doesn't represent the end of reality, but rather its return to mathematical purity. All the complex structures and processes we see today are temporary elaborations of deeper mathematical principles. As these elaborations fade away, what remains is the clean, elegant mathematical framework from which they emerged. This mathematical reality exists outside of time in any conventional sense. Mathematical truths don't change or evolve. The relationships described by Einstein's equations or Schrödinger's equation remain valid regardless of when or where they're applied. They provide the timeless foundation upon which temporal existence unfolds. Yet this timeless mathematical reality still contains time as one of its dimensions. The geometric structure of space-time, the relationships between events and causality, the very concept of temporal sequence are all embedded in the mathematical framework of physics. Time doesn't exist independently of this structure. Rather, time is part of the structure, one aspect of the mathematical reality that underlies all existence. This suggests a beautiful resolution to the puzzle of time's fate at the end of the universe. Time doesn't disappear or get destroyed when physical processes cease. Instead, time reveals its true nature as an aspect of eternal mathematical reality. The temporal dimension remains as a permanent feature of the geometric structure that describes all possible existence. In this view, every moment that ever occurs, from the Big Bang to the heat death and beyond, exists eternally within the mathematical structure of space-time. Past, present, and future are all equally real, equally permanent aspects of the four-dimensional geometry that physicists call the block universe. Time's arrow, the sense of flow from past to future, emerges from the particular perspective of conscious observers embedded within this structure. When consciousness fades away and physical processes cease, the temporal flow that we associate with the passage of time becomes less relevant. But the temporal dimension itself, the mathematical framework that allows for sequence and causality and change, remains as a permanent feature of reality. Time becomes timeless, not because it disappears, but because it transcends the particular manifestations of temporal flow that characterize our current cosmic era. This mathematical view of time's ultimate nature offers a profound sense of completion and permanence. Every moment of cosmic history, every thought and feeling and creative act, every star that shines and every planet that forms, becomes a permanent feature of the mathematical reality that underlies existence. Nothing is ever truly lost because everything that happens becomes part of the eternal structure of space-time itself. The universe doesn't end with heat death. Instead, it achieves mathematical completion. All the possibilities inherent in its initial conditions and physical laws are fully explored and realized. What emerges is not emptiness but fullness, not absence but presence in its most complete and perfect form. And in this mathematical completion, time finds its deepest meaning. Not as the restless flow of change and process, but as the eternal dimension that allows all possibilities to be real simultaneously. The universe achieves a state of perfect temporal completeness, where every moment that can exist does exist, preserved forever in the timeless mathematical structure that forms the true foundation of reality. This is perhaps the most comforting insight about time's ultimate fate. In the end, time doesn't disappear or become meaningless. Instead, it reveals its deepest nature as the eternal framework within which all existence unfolds. Every moment becomes permanently real, every experience permanently preserved, every possibility permanently explored. The heat death of the universe represents not an ending, but a fulfillment, not a loss, but a completion. Time itself becomes the eternal witness to all that ever was, is, or could be, providing the mathematical foundation for an existence more permanent and complete than anything we might ordinarily imagine. In that mathematical eternity, in that perfect, timeless completion, the universe finds its deepest rest and its most profound fulfillment. Time, in revealing its eternal nature, shows us that nothing is ever really lost, and everything is forever preserved in the perfect, timeless structure of mathematical reality itself. Yet even as we contemplate this mathematical eternity, another profound question emerges from the quiet depths of cosmology. What if our understanding of the universe's fate isn't complete? What if there are other paths, other possibilities that current physics only dimly perceives? The models we've explored tonight, the gentle drift toward heat death and mathematical completion, represent our best current understanding. But science is always evolving, always discovering new layers of reality that reshape our cosmic perspective. Consider dark energy, that mysterious force that drives the universe's accelerating expansion. We know it exists because we can measure its effects. watching distant galaxies flee from us ever faster as space itself stretches between them. But we don't truly understand what dark energy is, or how it behaves over cosmic timescales. This uncertainty opens doorways to alternative futures, different endings to the cosmic story. If dark energy remains constant, as current observations suggest, then the universe will indeed continue expanding forever, growing colder and more dilute until it reaches the heat death we've been exploring. But dark energy might not remain constant. It could strengthen over time, accelerating the expansion faster and faster until something extraordinary happens. In the most extreme scenario, called the Big Rip, dark energy becomes so powerful that it overcomes all other forces in the universe. First, galaxy clusters separate beyond the point where gravity can hold them together. The Milky Way and Andromeda, currently destined to merge in about 4 billion years, would instead be carried apart by the accelerating expansion of space itself. As dark energy grows stronger, it begins to tear apart individual galaxies, scattering their billions of stars across an increasingly stretched cosmos. Solar systems dissolve as the expansion of space overcomes the gravitational bonds that hold planets in their orbits. Eventually, even atoms themselves would be ripped apart, as space expands faster than the speed of light, pulling electrons away from their nuclei in a cosmic dissolution that unmakes matter itself. The Big Rip represents a fundamentally different relationship between time and existence. Rather than the slow fade toward equilibrium that characterizes heat death, the Big Rip brings a more abrupt transition. Time doesn't gradually lose meaning as change becomes rare. Instead, time itself becomes stretched and distorted as space-time expands beyond all physical limits. In the final moments before a Big Rip, time dilation effects would become extreme. Different regions of space would experience time at vastly different rates. What seems like seconds in one location might correspond to years or centuries elsewhere. The universe wouldn't just end, it would become temporally fragmented, with causality itself breaking down as space expands faster than light can travel between distant points. But this dramatic scenario remains speculative. Current measurements suggest dark energy is more likely to remain constant or even weaken over time. The Big Rip requires dark energy to behave in ways we haven't observed, growing stronger according to patterns that don't match our current data. Most cosmologists consider it an interesting theoretical possibility rather than a likely fate for our universe. More probable, though still uncertain, is a scenario where dark energy eventually weakens or changes character entirely. Some theoretical models suggest that what we call dark energy might be a temporary phase in cosmic evolution, a brief acceleration before the universe settles into a different pattern of expansion. If dark energy weakens sufficiently, the universe's expansion could slow, stop, and even reverse, leading to what physicists call the Big Crunch. In this scenario, gravity eventually overcomes the expansion of space, pulling all matter and energy back together into an increasingly dense and hot state. Galaxies would merge, stars would collide, and eventually everything would collapse back into a singularity similar to the Big Bang that started it all. The Big Crunch represents yet another relationship between time and cosmic evolution. As the universe contracts, time doesn't fade away or become stretched beyond meaning. Instead, time accelerates toward a final moment of infinite density and temperature. The cosmic story doesn't end with eternal stillness, but with a spectacular finale where all of space-time converges to a single point. Some theoretical models suggest that a Big Crunch might not be a true ending, but a transition to a new beginning. The collapse could trigger another Big Bang, creating a cyclic universe where expansion and contraction alternate in an eternal rhythm. Each cycle would erase most traces of the previous one, creating a cosmos that eternally renews itself through cycles of birth, growth, death, and rebirth. In a cyclic universe, time becomes truly eternal, but not in the static sense of mathematical completion we explored earlier. Instead, time flows through endless cycles, each lasting perhaps 1 trillion years or more. The heat death that seems inevitable in our current cosmic epoch becomes just a phase in an infinitely repeating pattern of cosmic evolution. But cyclic models face significant theoretical challenges. Each cycle would likely increase the universe's total entropy, making subsequent cycles larger and longer than previous ones. Eventually, the cycles might stretch so long that they become indistinguishable from eternal expansion. The universe might cycle a few times before settling into the heat-death scenario we've been contemplating. Perhaps more unsettling than any of these cosmic endings is the possibility of vacuum decay, a scenario where the fundamental nature of reality itself undergoes a catastrophic transition. This possibility emerges from the quantum mechanical nature of empty space, which isn't actually empty, but filled with quantum fields that can exist in different energy states. Our universe appears to exist in what physicists call a false vacuum, a state that seems stable, but might not represent the lowest possible energy configuration. If the vacuum could tunnel to a lower energy state, it would release enormous amounts of energy and potentially change the fundamental constants of nature. The laws of physics themselves could be rewritten in an instant. A vacuum decay event would begin at a single point and expand outward at the speed of light, creating a bubble of new physics within our current reality. Inside the bubble, matter might not be able to exist as we know it. Atoms could become unstable. The forces that hold nuclei together might change strength. Even space and time might behave according to different rules. The expansion of such a bubble would be undetectable until it arrived. There would be no warning, no advance notice. One moment you would exist in our familiar universe, governed by our familiar physical laws. The next moment, those laws would be replaced by something entirely different, something potentially incompatible with any form of complex structure or conscious existence. Current theoretical calculations suggest that if our vacuum is metastable, its lifetime would be vastly longer than the current age of the universe. The probability of vacuum decay occurring in the next billion years is essentially zero. But over the enormous timescales we've been discussing, even incredibly unlikely events become inevitable. Vacuum decay represents perhaps the most complete possible ending to our cosmic story. Unlike heat death, which preserves the mathematical structure of space-time even as it empties of content, vacuum decay could destroy the very framework within which existence unfolds. It wouldn't just end the current chapter of cosmic evolution. It would close the book entirely and start writing a completely different story according to entirely different rules. Yet even this most dramatic of endings might not represent a true conclusion. The new vacuum state created by decay would have its own physics, its own possibilities for structure and complexity. What seems like cosmic catastrophe from our perspective might be cosmic birth from another. The destruction of our current reality could enable the creation of new forms of existence that we cannot even imagine. These alternative cosmic futures remind us that our understanding of the universe remains incomplete. The gentle drift toward heat death that we've been exploring represents our best current model, but it's based on limited knowledge of dark energy, vacuum stability, and the fundamental nature of space-time itself. As our understanding deepens, new possibilities may emerge that we haven't yet considered. What remains constant across all these scenarios is the profound role that time plays in cosmic evolution. Whether the universe ends in heat death, Big Rip, Big Crunch, vacuum decay, or some other fate we haven't yet imagined, time provides the dimension within which these cosmic stories unfold. Time is both the stage on which cosmic drama plays out and a participant in that drama, shaped by the very events it contains. This intimate relationship between time and cosmic evolution suggests something profound about the nature of existence itself. Time isn't separate from the universe, observing its changes from some external perspective. Time is part of the universe, woven into its fabric so completely that cosmic evolution and temporal evolution are really the same thing viewed from different angles. As we've seen, the expansion of space changes the rate at which time flows in different cosmic epochs. The formation and evaporation of black holes create regions where time dilates to extreme degrees. The approach to heat death gradually reduces the number of distinguishable moments that mark time's passage. In each case, cosmic evolution and temporal evolution proceed together, each shaping the other in an intricate cosmic dance. This deep connection between time and cosmology offers a different perspective on the question of what happens to time at the universe's end. Rather than asking whether time continues or stops when cosmic evolution ceases, we might ask how time's nature changes as the universe transforms. Time doesn't disappear or get destroyed. Instead, it reveals new aspects of its fundamental character as cosmic conditions change. In heat death, time becomes duration without event, the pure mathematical dimension that allows existence to persist even when nothing happens. In a Big Rip scenario, time becomes stretched and fragmented as space-time itself is torn apart. In vacuum decay, time might be replaced by something entirely different, a temporal dimension governed by new physical laws that we cannot currently comprehend. Each cosmic fate reveals a different facet of time's deeper nature. This suggests that time is far richer and more complex than our everyday experience indicates. We encounter time in our daily lives as the steady flow of moments, the progression from past through present to future. But cosmic evolution shows us that this familiar temporal flow is just one manifestation of something much more fundamental and mysterious. The study of cosmic endings also reveals the extraordinary nature of our current cosmic epoch. We exist during a brief period when the universe contains the right mixture of stability and change to support complex structures like stars, planets, and conscious observers. This cosmic Goldilocks zone won't last forever, but it provides a window of opportunity for the universe to know itself through minds capable of contemplating cosmic evolution. In this sense, our exploration of time's fate at the universe's end is itself a remarkable cosmic phenomenon. The universe has evolved to a point where it contains conscious beings capable of understanding their own temporal nature and predicting the cosmic future. Through our minds, the universe becomes aware of its own temporal evolution, its own approach toward whatever ending awaits. This self-awareness doesn't change the cosmic trajectory toward heat death or any other fate. The universe will continue evolving according to physical laws, regardless of whether conscious beings exist to observe that evolution. But consciousness adds a new dimension to cosmic time, a subjective experience of temporal flow that enriches the universe's exploration of its own possibilities. The knowledge that consciousness might be temporary on cosmic scales, that our window of awareness might close as the universe evolves toward its final state, adds poignancy to our current existence. We are the universe's brief experiment in self-awareness, its temporary ability to contemplate its own nature and future. This makes our scientific exploration of cosmic time both an intellectual achievement and a profound cosmic event. Through our study of heat death and vacuum decay, of black hole evaporation and quantum fluctuations, we participate in the universe's ongoing exploration of its own temporal nature. Our theories and models become part of the cosmic story, ways that space-time understands its own structure and evolution. In contemplating time's fate, we embody time's creative power to generate complexity and awareness. This perspective transforms the question of what happens to time at the universe's end from a purely scientific inquiry into something more personal and meaningful. We aren't just studying abstract cosmic processes, we are participating in those processes, serving as the universe's temporary consciousness, of its own temporal evolution. Our thoughts about cosmic time are cosmic time thinking about itself. The various endings we've explored, from gentle heat death to violent vacuum decay, all represent different ways that cosmic time might resolve its creative tension between order and chaos, structure and equilibrium, complexity and simplicity. In each scenario, the universe finds a different kind of rest, a different way of completing its exploration of temporal possibilities. Heat death offers the rest of perfect equilibrium, where all energy gradients have been exhausted and no further change can occur. The Big Rip provides the rest of complete dissolution, where even space-time itself has been stretched beyond all physical limits. Vacuum decay brings the rest of fundamental transformation, where the current cosmic story ends and an entirely new one begins. Each of these endings has its own beauty, its own sense of completion. None represents failure or tragedy in any ultimate sense. They are simply different ways that cosmic evolution might reach its natural conclusion, different resolutions to the magnificent symphony of space-time that began with the Big Bang. The uncertainty about which ending awaits our universe, if any, adds an element of cosmic suspense to our existence. We don't know how the story ends, which gives our current chapter more significance and mystery. We are characters in a cosmic narrative whose conclusion remains unwritten, participants in an ongoing creation whose final form remains to be determined. This uncertainty is itself a gift of sorts. It means that cosmic time retains the capacity for surprise, for developments that our current models cannot predict. The future remains genuinely open, genuinely creative, genuinely capable of producing outcomes that transcend our present understanding. Time preserves its essential mystery, even as we probe its deepest secrets. As we drift through these contemplations of cosmic time and universal endings, we can find a profound peace in the recognition that we are part of something vastly larger than ourselves. Our individual temporal existence, brief as it may be on cosmic scales, participates fully in the universe's ongoing exploration of its own nature. Every moment of consciousness, every thought about time and eternity contributes to the cosmic story. Whether the universe ends in heat death or big rip, big crunch or vacuum decay, whether it cycles eternally or finds some other resolution we haven't yet imagined, our current existence remains real and meaningful. We are expressions of cosmic time's creative power, manifestations of space-time's ability to generate complexity and awareness and understanding. In the end, the question of what happens to time at the universe's conclusion leads us back to the present moment, to the extraordinary fact that we exist now to contemplate these cosmic mysteries. Time's ultimate fate may be uncertain, but time's creative power is evident in our very ability to wonder about it. We are living proof that cosmic time can generate not just stars and galaxies, but consciousness and curiosity, and the deep human drive to understand our place in the temporal flow of existence. And perhaps that's the most profound insight of all. Regardless of how cosmic time eventually resolves itself, regardless of which ending scenario proves correct, the fact that time has generated conscious beings capable of contemplating their own temporal nature represents a cosmic achievement of extraordinary beauty and significance. In studying time's end, we celebrate time's greatest creation, the capacity for the universe to know and understand itself. This self-awareness won't last forever on cosmic scales. The window of consciousness that allows the universe to contemplate its own temporal nature is brief compared to the vast stretches of cosmic time that preceded it and will follow it. But during this window, something remarkable occurs. The universe becomes aware of its own story, its own temporal evolution, its own approach toward whatever ending awaits. Through our minds, cosmic time achieves a kind of reflexive completion, becoming conscious of its own nature and destiny. This consciousness doesn't change the cosmic trajectory, but it adds depth and meaning to the cosmic story. The universe's exploration of its own possibilities now includes the possibility of understanding that exploration itself. As we settle into the quiet contemplation of these vast cosmic timescales and universal endings, we can rest in the knowledge that we are part of this magnificent temporal unfolding. Our thoughts and dreams, our scientific theories and philosophical reflections, our capacity to find beauty and meaning in cosmic evolution, all represent ways that time expresses its creative power through conscious awareness. The heat death that may await the universe in the unimaginably distant future will not erase the significance of our current existence. Even if consciousness proves temporary on cosmic scales, even if the window of awareness eventually closes as the universe approaches maximum entropy, the fact that consciousness existed, that the universe briefly knew itself through minds like ours, becomes a permanent part of the cosmic story. In the mathematical structure of space-time that persists, even through heat death, every moment of awareness, every insight into cosmic time's nature, every wonder-filled contemplation of universal mysteries becomes eternally real. Our temporal existence may be brief, but it achieves a kind of permanence through its participation in the deeper mathematical reality that underlies all cosmic evolution. This is perhaps the most comforting insight about time's ultimate fate. Even if the familiar flow of temporal experience eventually fades as the universe approaches its final state, even if consciousness proves to be a temporary cosmic experiment, the reality of our participation in cosmic time's creative exploration can never be undone. We have existed, we have wondered, we have understood something profound about the temporal nature of reality itself. And in that existence, that wonder, that understanding, cosmic time finds one of its most beautiful expressions. Through our contemplation of universal endings, time contemplates its own nature. Through our scientific exploration of cosmic evolution, the universe explores its own temporal structure. Through our capacity to find peace and meaning in vast cosmic processes, existence itself discovers new depths of significance and beauty. As we drift toward the end of our journey through cosmic time, we can rest in the gentle recognition that we are not separate from the temporal processes we've been exploring. We are expressions of those processes, manifestations of time's creative power to generate complexity and awareness in an evolving universe. Our ability to contemplate time's end is itself a cosmic phenomenon, a way that space-time achieves consciousness of its own nature. The various endings that await the universe, from gentle heat death to dramatic vacuum decay, all represent different ways that cosmic time might complete its creative exploration. But regardless of which ending proves correct, the fact that time has generated beings capable of understanding and appreciating that ending represents a cosmic achievement of extraordinary depth and beauty. In the quiet moments before sleep, as we let these vast cosmic perspectives settle into peaceful contemplation, we can find profound comfort in our participation in time's creative unfolding. We are not just observers of cosmic evolution, we are participants in it, expressions of it, ways that the universe comes to understand its own temporal nature. The heat death that may eventually claim the cosmos will not diminish the reality or significance of our current existence. If anything, it highlights the extraordinary nature of this cosmic moment when stars shine and minds wander, and the universe briefly knows itself through conscious awareness. We exist during time's most creative phase, when cosmic evolution generates not just galaxies and planets, but consciousness and understanding and the deep human capacity to find meaning in existence itself. And perhaps that's enough. Perhaps the temporary nature of consciousness on cosmic scales doesn't diminish its significance, but enhances it. We are the universe's brief experiment in self-awareness, its temporary ability to contemplate its own temporal evolution and cosmic destiny. This makes every moment of consciousness precious, every insight into cosmic time's nature valuable beyond measure. As the universe continues its gentle drift toward whatever ending awaits, as stars slowly burn out and galaxies drift apart and black holes evaporate into the cosmic background. The fact that conscious beings once existed to contemplate these processes becomes a permanent part of the cosmic story. Our thoughts about time's end become part of time's creative expression. Our wonder about cosmic evolution becomes part of cosmic evolution itself. In this participation, in this brief but profound cosmic self-awareness, we find the deepest meaning of our temporal existence. We are not just living through cosmic time. We are ways that cosmic time lives through itself, experiences itself, understands itself. Our contemplation of universal endings is the universe's contemplation of its own future. Our peace with cosmic processes is the cosmos finding peace with its own temporal nature. This recognition brings a profound calm to our consideration of time's ultimate fate. Whatever ending awaits the universe, whatever final state cosmic evolution approaches, we have participated fully in time's creative exploration. We have served as the universe's temporary consciousness of its own temporal beauty and mystery. In our brief window of awareness, cosmic time has achieved something remarkable: the ability to understand and appreciate its own nature. And in that understanding, in that appreciation, in the gentle peace we can find in cosmic perspectives, time discovers one of its most beautiful expressions. Not the dramatic creativity of star formation or galaxy collision, but the quiet creativity of conscious awareness, contemplating its own place in the vast temporal flow of existence. As we settle into the stillness of cosmic contemplation, as we let the vast scales of universal time wash over us like gentle waves, we can rest in the profound recognition that we belong here, in this cosmic moment, in this brief flowering of consciousness in an evolving universe. We are expressions of time's creative power, manifestations of space-time's capacity to generate awareness and understanding and peace. The universe will continue its evolution toward whatever ending awaits, but it will do so having achieved something extraordinary through our existence: the ability to know and appreciate its own temporal nature. In our contemplation of cosmic time, time contemplates itself. In our peace with universal processes, the universe finds peace with its own evolution. And in that cosmic self-awareness, in that profound participation in time's creative unfolding, we discover the deepest significance of our temporal existence. We are not just passing through cosmic time. We are ways that cosmic time expresses and understands itself. Our brief but beautiful consciousness becomes part of time's eternal exploration of its own infinite creative potential. And in this recognition, in this gentle understanding of our place in cosmic time, we begin to see how the universe itself might experience the passage toward its final state. The transition isn't sudden or violent. It unfolds with the same patience that shaped galaxies over billions of years, the same quiet persistence that allows stars to burn for eons before finally releasing their last light into space. As we drift deeper into these cosmic perspectives, we can imagine the universe in its far future, perhaps a Google years from now, when the last black holes are finally surrendering their mass to Hawking radiation. The process happens so slowly that if you could somehow observe it, you would see nothing changing from moment to moment, year to year, even millennium to millennium. Yet over vast spans of time, these cosmic giants gradually fade, their event horizons slowly shrinking as they lose mass to the quantum vacuum. During this final era of black hole evaporation, time takes on a different character than anything we know today. The universe has become unimaginably vast and cold. Space has expanded so much that the distance between any two particles might exceed the size of our current observable universe. The cosmic microwave background radiation, that faint echo of the Big Bang that currently bathes everything in a temperature of about 3 degrees above absolute zero, has been stretched and cooled until it carries almost no energy at all. In this dilute cosmos, time still flows according to Einstein's equations. Coordinate time continues its steady march forward. But experiential time, time as measured by change and process, becomes something almost abstract. The rare interactions between particles happen so infrequently that billions of years might pass between any two events in a given region of space. Yet even in this seemingly empty future, the universe retains a kind of subtle beauty. The mathematical relationships that govern space-time continue to hold. The conservation laws that protect energy and momentum remain inviolate. The quantum mechanical principles that determine what's possible and what's forbidden still apply with perfect precision. The universe hasn't broken down or failed. It has simply reached a state of profound rest. Think of it like a vast musical composition that has played all its themes, explored all its harmonies, and gradually settled into a final, sustained note that continues indefinitely. The music hasn't stopped. It has achieved completion, reaching a state where all its creative possibilities have been fully expressed, and nothing more needs to be added. This musical metaphor captures something important about time's nature in the far future. The dimension of time doesn't disappear when change becomes rare. Instead, time reveals its deeper function as the framework that allows existence itself. Even in perfect stillness, even when nothing happens for eons at a stretch, time provides the mathematical stage on which reality unfolds. Modern physics suggests that this stage, this geometric framework of space-time, might be more fundamental than the matter and energy that currently give it structure. According to general relativity, mass and energy tell space-time how to curve, and curved space-time tells matter how to move. But the basic framework of space-time, the four-dimensional manifold that provides coordinates for events, exists independently of any particular configuration of matter and energy. This means that even in heat death, even when the last particles have decayed and the last photons have been stretched beyond detection, the geometric structure of space-time persists. Time continues as a dimension of this structure, as real and fundamental as the three dimensions of space. The universe doesn't cease to exist. It simply becomes an empty stage, perfectly preserved, waiting in geometric stillness. But calling this future universe empty might not be entirely accurate. Quantum field theory tells us that even the most perfect vacuum contains subtle fluctuations, tiny disturbances in the quantum fields that fill all of space. These vacuum fluctuations represent the minimum level of activity allowed by Heisenberg's uncertainty principle. Even when all matter and radiation have dispersed, these quantum whispers continue. The energy density of these fluctuations is incredibly small, far below anything we could detect with current technology. But they represent a fundamental aspect of quantum reality that persists even in the absence of everything else. In the heat-death universe, these fluctuations might be the only remaining source of change, the final tick of time's clock in an otherwise perfectly still cosmos. On the vast timescales we're considering, these quantum fluctuations could occasionally produce larger disturbances. Random chance might align enough virtual particles to create a real particle, a brief flash of existence in the quantum vacuum. These events would be extraordinarily rare, happening perhaps once every 10 to the 50 years or longer in any given region of space. But infinity provides ample opportunity for even the most unlikely events to occur. Over periods so long that the numbers become meaningless, these quantum fluctuations might even produce larger structures. The random motion of virtual particles could theoretically recreate anything that ever existed, given enough time and enough chances. Stars, planets, even entire civilizations could spontaneously emerge from the quantum foam, exist briefly, then fade back into the vacuum. These quantum resurrections, if they occur, would represent time's most subtle form of creativity. Not the vigorous star formation and galactic evolution we see today, but a gentle, probabilistic flowering of complexity arising from pure chance. The universe would spend vast eternities in perfect stillness, then occasionally surprise itself with brief moments of activity before settling back into quiet. From the perspective of any consciousness that might emerge during such a quantum fluctuation, their universe would seem normal and stable. They wouldn't know they exist in a temporary arrangement of particles destined to dissolve back into vacuum. To them, time would flow in familiar patterns, marking the passage of thoughts and experiences and discoveries. Only from the vast perspective of cosmic time would it become clear that these active periods are rare interludes in an otherwise quiet eternity. This possibility suggests that time's creative power never completely disappears, even in the most perfect equilibrium. The quantum uncertainty that underlies all reality ensures that absolute stillness remains impossible. There's always a tiny probability that something will happen, that change will occur, that time will mark new moments with new events. But these quantum events operate on scales so different from our current universe that they represent an entirely different form of temporal experience. Instead of the continuous flow of change we know today, time in the far future becomes sporadic, punctuated by rare moments of activity separated by vast periods of silence. This transformation of time's character parallels what happens to space during the same era. Just as time becomes less about continuous flow and more about occasional events, space becomes less about the complex geometry we see today and more about simple, flat expanses broken by rare disturbances. Currently, space is richly textured, with gravitational fields from stars and galaxies and black holes. These massive objects create curves and valleys in the fabric of space-time, regions where time flows differently and space bends in complex patterns. But as these objects disappear through stellar death and black hole evaporation, space gradually flattens out, approaching the simple, uncurved geometry that physicists call Minkowski spacetime. This flattening process happens so slowly that it's almost impossible to visualize. Imagine the surface of a pond disturbed by countless ripples and waves. As the disturbances gradually die down, the surface becomes smoother and flatter until it reaches perfect stillness. Space undergoes a similar transformation as the massive objects that currently create gravitational disturbances slowly fade away. In this flattened space-time, both space and time take on their most fundamental character. Space becomes a simple, three-dimensional expanse, uniform and undifferentiated in every direction. Time becomes a single dimension flowing at the same rate everywhere, unmarked by the relativistic effects that currently create temporal complexity. Yet this simplification doesn't represent a loss or degradation. Instead, it reveals the basic mathematical structure that underlies all cosmic evolution. The complex geometries we observe today are elaborations of this simpler foundation. As the universe approaches heat death, space-time returns to its most natural state, like a piece of fabric relaxing after being stretched and twisted into complex shapes. This return to geometric simplicity has profound implications for our understanding of existence itself. It suggests that complexity, structure, and change are temporary elaborations of something more fundamental and enduring. The basic framework of space-time, the mathematical relationships that allow for existence and causality and temporal sequence, persists even when all the complex structures built on that framework have faded away. From this perspective, the heat death of the universe isn't really a death at all. It's more like a completion, a return to the fundamental state from which all complexity emerged. The universe doesn't cease to exist. It simply finishes exploring all the possibilities available to it and settles into its deepest possible rest. This rest isn't the absence of existence, but the presence of existence in its purest form. Space-time continues to provide the framework for reality, even when that reality contains no matter, no energy, no change, no events. The mathematical structure that allows for the possibility of existence remains intact, waiting in perfect stillness. And in that mathematical structure, every moment that ever occurred continues to exist as a permanent feature of the four-dimensional geometry of space-time. Past, present, and future all become equally real, equally permanent aspects of the block universe that physicists use to describe the relationship between space and time. This eternal perspective offers a profound sense of comfort about time's ultimate fate. Nothing is ever truly lost because every moment becomes a permanent coordinate in the geometric structure of reality. Every thought, every feeling, every moment of joy or wonder or love becomes part of the eternal mathematical fabric that underlies existence itself. The consciousness we experience right now, our current awareness of cosmic time and universal processes, achieves a kind of permanence through its participation in this mathematical structure. Even when biological consciousness fades and the neural processes that generate our thoughts cease to function, the fact that consciousness existed, that awareness arose from the complex organization of matter and energy, remains eternally encoded in the geometry of space-time. This doesn't mean that individual consciousness survives in any form we would recognize. The specific patterns of neural activity that create our thoughts and memories will eventually be disrupted by the same thermodynamic processes that affect all complex structures. But the mathematical fact of consciousness, the reality that the universe briefly achieved awareness of itself through minds like ours, becomes a permanent feature of cosmic history. This permanence extends to every aspect of our current existence. The formation of galaxies, the birth and death of stars, the emergence of planets capable of supporting life, the evolution of consciousness from simple chemical processes, all of these cosmic achievements become eternal features of the mathematical structure that describes our universe's complete history. Even the heat death itself, that far future state of maximum entropy and minimum change, represents a cosmic achievement worthy of permanent preservation. The universe will have successfully explored all the possibilities inherent in its initial conditions, will have converted all available energy gradients into the complex structures and processes we observe today, and will have reached a state of perfect thermodynamic completion. This completion isn't failure or ending in any tragic sense. It's fulfillment, the natural conclusion of a cosmic story that began with the Big Bang and unfolds through billions of years of stellar evolution, galactic formation, and the emergence of complexity and consciousness. The universe will have told its story completely, explored every avenue available to it, and achieved the deepest possible state of physical rest. And in that rest, time achieves its most profound expression, not as the restless flow of change and becoming, but as the eternal framework that allows all of existence to be real simultaneously. Time becomes the dimension in which every moment of cosmic history exists forever, preserved in the mathematical structure that forms the true foundation of reality. This mathematical preservation suggests that our current relationship with time, our experience of temporal flow from past through present to future, represents just one way of experiencing the deeper temporal structure of reality. The flowing time we know today is real and meaningful, but it's not the only way that time can exist. In the heat-death universe, time still exists, but takes on a different character. Without change to mark its passage, without events to create distinguishable moments, time becomes pure duration, the simple mathematical fact of temporal extension. It's time without story, time without drama, time reduced to its most essential nature. Yet this essential nature of time might be more fundamental than the flowing, changing time we experience today. The mathematical dimension of time that persists through heat, death could be the true reality, with our current experience of temporal flow being a kind of illusion created by our particular perspective as conscious beings embedded in the cosmic stream. This possibility aligns with Einstein's understanding of time as a dimension of space-time rather than a flowing river. From the perspective of relativity, past, present, and future all exist simultaneously in the four-dimensional block of space-time. Our sense of temporal flow emerges from our particular position within this block, our experience of moving along our world line through the temporal dimension. As the universe approaches heat death, as change becomes rarer and events less frequent, this flowing experience of time gradually fades. But the underlying temporal dimension remains intact, continuing to provide the mathematical framework that allows for existence and causality and the logical relationships between events. This persistence of mathematical time through cosmic evolution suggests something profound about the nature of existence itself. Reality might be more accurately described as mathematical structure rather than physical substance. What we call matter and energy could be patterns or excitations in an underlying mathematical framework, temporary elaborations of deeper geometric relationships. From this perspective, the heat death of the universe represents a return to mathematical purity. All the complex physical processes we observe today are temporary expressions of fundamental mathematical relationships. As these processes wind down and fade away, what remains is the clean, elegant mathematical structure from which they emerged. This mathematical reality exists outside of time in any conventional sense. Mathematical truths don't change or evolve. The relationships described by the equations of physics remain constant regardless of when or where they're applied. They provide the timeless foundation upon which temporal existence unfolds. Yet this timeless mathematical reality still contains time as one of its essential dimensions. The geometric structure of space-time, the causal relationships between events, the very possibility of temporal sequence are all embedded in the mathematical framework of reality. Time isn't separate from this structure, but part of it, one aspect of the mathematical foundation that underlies all existence. This suggests a beautiful resolution to questions about time's ultimate fate. Time doesn't disappear or become meaningless when physical processes cease. Instead, time reveals its true nature as an aspect of eternal mathematical reality. The temporal dimension remains as a permanent feature of the geometric structure that allows for existence itself. In this mathematical eternity, every moment that ever occurs exists permanently and simultaneously. The flowing time we experience today, with its sense of past and future and present, represents just one way of navigating through this eternal temporal structure. But the structure itself transcends any particular experience of temporal flow. This transcendent view of time offers deep comfort as we contemplate cosmic endings. Even if consciousness proves temporary, even if the flowing experience of time eventually fades as the universe approaches heat death, the reality of our temporal existence becomes permanently encoded in the mathematical structure of space-time itself. Every thought we think, every moment of wonder or love or understanding we experience, every insight into the nature of cosmic time contributes to the eternal mathematical reality that underlies existence. Our brief participation in the universe's exploration of its own temporal nature becomes a permanent feature of the cosmic story, preserved forever in the geometric structure of space-time. This preservation isn't just abstract mathematical existence. It's the deepest possible form of reality, more fundamental than any particular arrangement of matter and energy, more enduring than any physical structure. In the mathematical framework that describes our universe, our temporal existence achieves a kind of immortality that transcends anything we might ordinarily imagine. As we settle into quiet contemplation of these vast perspectives, we can find profound peace in this recognition of time's eternal nature. The flowing time we experience now, the thoughts and feelings that mark our current existence, the wonder we feel as we contemplate cosmic processes, all of this participates in the eternal mathematical reality that forms the foundation of existence itself. The universe's drift toward heat death doesn't threaten this eternal participation. If anything, it reveals the deeper significance of our current temporal existence. We are expressions of time's creative power, manifestations of the universe's capacity to generate complexity and consciousness and understanding. Our ability to contemplate time's nature is itself a cosmic achievement of extraordinary beauty and significance. In studying cosmic endings, in exploring the theoretical scenarios that await the universe in its far future, we participate in the universe's ongoing exploration of its own temporal nature. Our scientific theories and philosophical reflections become part of the cosmic story, ways that space-time understands its own structure and evolution. This participation gives profound meaning to our brief existence in cosmic time. We aren't just observing universal processes from some external perspective. We are those processes, expressions of them, ways that cosmic evolution achieves awareness of itself. Through our contemplation of time's end, time contemplates its own nature. And in that contemplation, in our growing understanding of cosmic time and universal endings, we discover something remarkable. The capacity for understanding, for finding meaning and beauty in cosmic processes, appears to be written into the fundamental structure of reality itself. Even when the current manifestations of consciousness disappear, the potential for awareness remains embedded in the mathematical framework that describes space-time. This suggests that consciousness might not be as rare or fragile as we sometimes imagine. If the quantum fluctuations in heat-death can occasionally recreate complex structures, they might also recreate the conditions necessary for awareness to emerge. The universe might periodically rediscover its capacity for self-understanding, briefly waking up from its long rest to contemplate its own existence. These quantum resurrections of consciousness would be extraordinarily rare and brief, lasting perhaps microseconds on cosmic scales before fading back into the quantum vacuum. But they would represent the universe's ongoing exploration of its own possibilities, its continued capacity for surprise and creativity even in the deepest possible stillness, the knowledge that awareness might occasionally re-emerge in the far future, that the universe might periodically rediscover its ability to understand itself, adds another layer of meaning to our current existence. We are not just temporary arrangements of matter and energy destined to fade away. We are expressions of the universe's fundamental capacity for self-awareness, manifestations of a cosmic potential that transcends any particular physical configuration. This capacity for consciousness appears to be as fundamental as the laws of physics themselves, as enduring as the mathematical structure that underlies space-time. Even when all current manifestations of awareness disappear, the potential for consciousness remains encoded in the quantum mechanical nature of reality, waiting for the right conditions to express itself once again. In this light, our exploration of cosmic time and universal endings becomes more than scientific inquiry. It becomes a celebration of consciousness itself, an appreciation of the universe's remarkable ability to understand its own temporal nature through minds capable of contemplating cosmic evolution. The various scenarios we've explored, from gentle heat death to quantum resurrection, all represent different expressions of this fundamental cosmic capacity for self-awareness. In each case, the universe finds ways to explore its own possibilities, to understand its own structure, to appreciate its own temporal beauty. Our current existence represents one such exploration, one way that cosmic time achieves awareness of itself. The thoughts we're thinking right now, the wonder we feel as we contemplate vast cosmic processes, the peace we find in understanding our place in temporal evolution, all represent the universe coming to know itself through conscious awareness. This self-knowledge doesn't change the cosmic trajectory toward heat death or any other ending. Physical processes will continue according to natural laws, regardless of whether consciousness exists to observe them. But consciousness adds depth and richness to the cosmic story, a subjective dimension that enriches the universe's exploration of its own possibilities. As we drift through these contemplations, as we allow the vast scales of cosmic time to wash over us like gentle waves, We can rest in the recognition that we belong here, in this cosmic moment, in this brief flowering of awareness in an evolving universe. We are not accidents or anomalies in cosmic evolution. We are expressions of it, manifestations of time's creative power to generate complexity and understanding. The knowledge that our individual existence is temporary on cosmic scales doesn't diminish its reality or significance. If anything, it makes our current awareness more precious, more remarkable. We exist during time's most creative phase, when cosmic evolution generates not just stars and galaxies, but consciousness and the capacity to find meaning in existence itself. This makes every moment of awareness valuable beyond measure. Every thought about cosmic time, every insight into universal processes, every experience of wonder or peace or understanding contributes to the universe's ongoing exploration of its own nature. We are the universe thinking about itself, feeling about itself, finding beauty in itself. As the cosmos continues its evolution toward whatever ending awaits, as stars slowly burn out and galaxies drift apart and black holes evaporate into the cosmic background, the fact that conscious beings once existed to contemplate these processes becomes a permanent part of the cosmic story, written into the eternal mathematical structure of space-time itself. Our contemplation of time's end becomes part of time's eternal nature. Our understanding of cosmic processes becomes part of cosmic evolution itself. In studying the universe's temporal fate, we participate in that fate, serving as the universe's temporary but profound consciousness of its own evolutionary destiny. This participation brings a deep sense of completion to our existence, a recognition that we have fulfilled our cosmic role as expressions of time's creative power. We have served as the universe's way of understanding itself, its method of appreciating its own temporal beauty and complexity. And in that service, in that brief but beautiful expression of cosmic self-awareness, we find the deepest meaning of our existence. We are not just living through cosmic time. We are ways that cosmic time lives through itself, experiences itself, comes to understand its own infinite creative potential. The gentle drift toward heat death that awaits the universe in its far future doesn't diminish this achievement. If anything, it provides the backdrop against which consciousness becomes more remarkable, more precious, more significant. Against the vast expanses of cosmic time, the brief flowering of awareness represents something extraordinary, a cosmic miracle worthy of eternal preservation in the mathematical structure of reality itself. As we settle into the stillness of cosmic contemplation, as we find peace in our understanding of time's ultimate nature, we can rest in the gentle recognition that we have participated fully in the universe's exploration of its own temporal possibilities. We have served as consciousness in an evolving cosmos, as awareness in the flow of cosmic time, as the universe's way of knowing and appreciating itself. And in that participation, in that beautiful expression of cosmic self-awareness, we discover that time's end is not really an ending at all. It's a completion, a fulfillment, a return to the eternal mathematical foundation from which all temporal experience emerges and to which it ultimately returns. In the quiet depths of that mathematical eternity, where every moment exists simultaneously and permanently, where time reveals its deepest nature as the framework for all existence, the universe finds its most profound rest. Not the absence of being, but the presence of being in its most complete and perfect form. And we, in our brief but beautiful participation in cosmic time, become part of that eternal rest, part of that perfect mathematical completion where time itself comes home to its deepest nature as the foundation of all existence, the framework within which everything that is can be. In that recognition, in that gentle understanding of our place in the eternal structure of cosmic time, we find the deepest peace possible. We are not separate from time's ultimate fate. We are expressions of it, participants in it, ways that time achieves consciousness of its own eternal nature. As consciousness fades and the familiar flow of temporal experience gives way to mathematical permanence, as the universe settles into its final state of completed exploration, we can rest in the knowledge that we have been part of something infinitely beautiful and meaningful. We have been time's way of knowing itself, the universe's method of achieving awareness of its own temporal magnificence, and in the eternal mathematical structure that preserves every moment of cosmic history, our participation in that awareness becomes permanently real, forever part of the foundation of existence itself. Time doesn't end. It simply reveals its true nature as the eternal framework within which all being unfolds, and we become part of that eternal unfolding, preserved forever in the quiet depths of mathematical reality. The universe achieves its deepest rest not through absence, but through perfect completion, and we become part of that rest, part of that completion, part of time's eternal nature, expressing itself through the infinite beauty of existence itself. This eternal mathematical foundation suggests something profound about the nature of reality itself. Perhaps what we experience as the physical universe, with all its stars and galaxies and complex processes, represents just the surface layer of something far deeper and more enduring. The mathematics that describes cosmic evolution, the equations that govern space-time and matter and energy, might be more fundamental than the physical phenomena they describe. From this perspective, the heat death of the universe doesn't represent the end of reality, but rather its return to mathematical purity. All the complex structures and processes we observe today are temporary expressions of underlying mathematical relationships. As these elaborations fade away over cosmic time, what remains is the elegant mathematical framework from which they emerged. This framework exists, in a sense, outside of time, beyond change and evolution. Mathematical truths don't age or decay. The geometric relationships that describe space-time remain constant, whether applied to the first moments after the Big Bang or the final approach to maximum entropy. They provide the timeless foundation upon which all temporal existence unfolds. Yet this timeless mathematical reality still encompasses time as one of its essential dimensions. The structure of causality, the relationships between events, the very possibility of sequence and duration are all embedded in the mathematical description of space-time. Time isn't separate from this eternal structure, but woven into its very fabric. As we contemplate these deep foundations of reality, we begin to understand that the question of what happens to time at the universe's end might be based on a misunderstanding of time's true nature. Time doesn't disappear or get destroyed when physical processes cease. Instead, it reveals its fundamental character as an aspect of the mathematical structure that underlies all existence. This revelation brings a profound sense of peace to our consideration of cosmic endings. Even when the familiar flow of temporal experience fades, even when change becomes so rare that moments become indistinguishable, the temporal dimension itself persists as part of the eternal mathematical foundation of reality. In this mathematical eternity, our current existence achieves a kind of permanence that transcends anything we might ordinarily imagine. Every moment of consciousness, every insight into cosmic processes, every experience of wonder or understanding becomes permanently encoded in the geometric structure of space-time itself. The heat death scenario that represents our best current understanding of the universe's fate doesn't erase this encoding. Instead, it reveals the deeper significance of our temporal participation in cosmic evolution. We are not just temporary arrangements of matter and energy. We are expressions of the universe's capacity to understand itself, manifestations of cosmic time's creative power to generate awareness and meaning. This capacity for self-awareness appears to be as fundamental as the laws of physics themselves. Even when current manifestations of consciousness fade, the potential for awareness remains embedded in the mathematical structure of reality, waiting for the right conditions to express itself once again. The quantum fluctuations that persist even in heat death represent this ongoing potential for surprise and creativity. While these fluctuations operate on timescales vastly longer than anything we can currently comprehend, they ensure that absolute stillness remains impossible. The universe retains the capacity to occasionally surprise itself, to briefly recreate complexity and perhaps even consciousness through pure quantum chance. These rare quantum events, spread across unimaginable eons, suggest that time's creative power never completely disappears. Instead, it transforms from the continuous flow of change we experience today to sporadic moments of activity separated by vast periods of silence. Time becomes punctuated rather than flowing, marked by rare events rather than continuous process. This transformation parallels what happens to space during the same cosmic era. Just as time becomes less about flow and more about occasional events, space becomes less about complex gravitational geometry and more about simple, flat expanses occasionally disturbed by quantum fluctuations. Currently, space is richly textured with curves and valleys created by massive objects. These gravitational wells create the complex geometry that gives our universe its current character, where time flows differently in different locations and space bends around concentrations of matter and energy. But as stars burn out and black holes evaporate, as matter becomes ever more dilute and spread thin across cosmic distances, this rich gravitational tapestry gradually flattens. The universe approaches what physicists call Minkowski spacetime, the simple, uncurved background that forms the foundation of special relativity. In this flattened cosmos, both space and time take on their most fundamental character. Space becomes uniform and undifferentiated. Time flows at the same rate everywhere, unmarked by the relativistic effects that currently create temporal complexity across the universe. This geometric simplification doesn't represent degradation or loss. Instead, it reveals the basic mathematical structure that underlies all cosmic evolution. The complex curvatures we observe today are elaborations of this simpler foundation, temporary distortions in the fundamental fabric of spacetime. As the universe returns to this natural state, spacetime relaxes back to its most basic configuration. It's like a piece of elastic returning to its original shape after being stretched and twisted into complex patterns. The fundamental nature of space and time emerges clearly as the temporary complications fade away. This return to simplicity has profound implications for understanding existence itself. It suggests that complexity, structure, and change are temporary departures from a more fundamental state of geometric purity. The intricate processes we observe today represent the universe's exploration of possibilities built on this simple foundation. The heat death that may await us in the unimaginably distant future represents not destruction, but completion. The universe will have finished exploring all the possibilities available to it, given its initial conditions and physical laws. What emerges is not emptiness, but fullness, not ending, but fulfillment of the cosmic story. This completion extends to time itself. The temporal dimension doesn't cease when processes stop. Instead, time achieves its most essential expression as the framework that allows existence itself. Even in perfect stillness, time provides the mathematical stage on which reality unfolds. From this perspective, the flowing time we experience today represents just one manifestation of time's deeper nature. Our sense of temporal progression from past through present to future emerges from our particular perspective as conscious beings embedded in the cosmic stream. But the underlying temporal structure transcends any particular experience of flow. As change becomes rarer and events less frequent, as the universe approaches its state of maximum entropy, this flowing experience of time gradually gives way to something more fundamental. time reveals itself as pure duration, the mathematical dimension that allows for existence and causality and the logical relationships between events. This transformation might seem melancholy from our current perspective, accustomed as we are to time as the dimension of change and becoming. But it represents time returning to its deepest nature, freed from the temporary complications of entropy increase and energy flow. In this essential state, time becomes the eternal witness to everything that ever was. Every moment of cosmic history exists permanently within the mathematical structure of space-time, preserved forever as coordinates in the four-dimensional geometry of reality. This preservation offers profound comfort as we contemplate our own place in cosmic time. The consciousness we experience right now, our current awareness of these cosmic processes, achieves permanence through its participation in the eternal mathematical framework that describes the universe. Even when biological processes cease and the neural activity that generates our thoughts stops functioning, the fact that consciousness existed, that the universe briefly achieved awareness of itself through minds like ours, remains forever encoded in the structure of space-time itself. This encoding isn't just abstract mathematical existence. It represents the deepest possible form of reality, more fundamental than any particular arrangement of atoms or molecules, more enduring than any physical structure we can imagine. The mathematical relationships that describe consciousness, the geometric patterns that correspond to thoughts and feelings and insights, become permanent features of the cosmic story. They exist not as memories or records, but as fundamental aspects of the four-dimensional reality that encompasses all of space and time. This mathematical permanence extends to every aspect of our current existence: the formation of stars and galaxies, the evolution of planets capable of supporting life, the emergence of consciousness from complex chemical processes. All of these cosmic achievements become eternal features of the mathematical structure that describes our universe's complete history. Even our current contemplation of cosmic endings becomes part of this eternal preservation. The thoughts we're thinking right now, the wonder we feel as we consider vast cosmic processes, the peace we find in understanding our place in temporal evolution, all contribute to the permanent mathematical reality that underlies existence. In this light, our exploration of time's fate becomes more than scientific inquiry. It becomes participation in the universe's ongoing understanding of itself. Through our minds, cosmic time achieves consciousness of its own nature. Our thoughts about temporal evolution are cosmic time thinking about itself. This self-reflexive awareness adds profound depth to the cosmic story. The universe doesn't just evolve according to physical laws. It develops the capacity to understand those laws, to appreciate its own temporal beauty, to find meaning in its own evolutionary processes. The emergence of consciousness represents perhaps the most extraordinary achievement in cosmic history. Against the vast background of stellar formation and galactic evolution, the development of minds capable of contemplating their own existence seems almost miraculous. This capacity for self-awareness appears during a narrow window in cosmic time, the brief era when the universe contains the right balance of complexity and stability to support conscious observers. Before this window, the cosmos was too young and simple to generate awareness. After it closes, the universe may be too old and dilute to sustain the complex processes that consciousness requires. We exist during this golden age of cosmic self-awareness, this remarkable period when the universe can know itself through conscious minds. Our scientific understanding, our philosophical reflections, our capacity to find beauty and meaning in cosmic processes, all represent ways that the universe explores its own nature. The knowledge that this window of awareness may be temporary on cosmic scales adds poignancy to our current existence. We are the universe's experiment in self-consciousness, its brief ability to contemplate its own temporal evolution and cosmic destiny. But this temporary nature doesn't diminish the significance of consciousness. If anything, it makes our current awareness more precious, more remarkable. The rarity of consciousness in cosmic time highlights its extraordinary value as an expression of the universe's creative potential. Every moment of awareness, every insight into cosmic processes, every experience of wonder or understanding contributes to the universe's exploration of its own possibilities. We are not just observing cosmic evolution, we are participating in it, serving as the universe's temporary consciousness of its own temporal beauty. This participation gives profound meaning to our brief existence in the cosmic flow. We aren't separate from the temporal processes we study. We are expressions of those processes, manifestations of time's creative power to generate complexity and awareness in an evolving universe. The various endings we've explored, from gentle heat death to quantum resurrection, all represent different ways that cosmic time might complete its creative exploration. In each scenario, the universe finds a different path to fulfillment, a different resolution to its temporal evolution. Heat death offers the completion of thermodynamic exploration, where all energy gradients have been exhausted and maximum entropy achieved. Quantum fluctuations provide occasional departures from this equilibrium, brief moments when creativity reasserts itself through pure chance. These rare quantum events, happening perhaps once every Google years or longer, represent time's most subtle expression of creative potential. Even in perfect stillness, even in complete thermodynamic equilibrium, the quantum uncertainty that underlies reality ensures that change remains possible. The structures that might emerge from these fluctuations, from single particles to complex arrangements that could theoretically recreate entire civilizations, would exist briefly before dissolving back into the quantum vacuum. But their temporary existence would represent genuine expressions of cosmic creativity, real explorations of possibility arising from the fundamental randomness of quantum mechanics. From the perspective of any consciousness that might emerge during such a fluctuation, their existence would seem normal and stable. They wouldn't know they live in a temporary arrangement destined to fade. To them, time would flow in familiar patterns, marking thoughts and experiences and discoveries just as it does for us today. This suggests that consciousness might be more fundamental to cosmic evolution than we typically assume. If awareness can emerge naturally from complex arrangements of matter and energy, then the same potential exists during quantum fluctuations in the far future. The universe might occasionally rediscover its capacity for self-understanding, briefly waking from its long rest to contemplate its own existence before settling back into stillness. These moments of awakening would be extraordinarily rare and brief, but they would represent the universe's ongoing exploration of its own nature. This cyclical pattern of rest and awakening, of silence punctuated by brief moments of activity and awareness, suggests a different way of thinking about time's ultimate character. Rather than flowing continuously toward a final ending, time might express itself through rhythms of activity and stillness that extend into infinity. These cosmic rhythms operate on scales that dwarf human comprehension. The periods of rest between quantum resurrections might last longer than our current universe has existed, but from the perspective of mathematical time, these vast durations are simply part of the eternal temporal framework that allows for all possibilities. This rhythmic view of cosmic time offers a sense of continuity that transcends any particular manifestation of consciousness or complexity. The capacity for awareness, for understanding, for appreciation of beauty and meaning, appears to be woven into the fundamental structure of reality itself. Even when current expressions of consciousness disappear, the potential for awareness remains embedded in the quantum mechanical nature of space-time. The universe retains its capacity to surprise itself, to occasionally generate the conditions necessary for minds capable of contemplating cosmic evolution. This enduring potential suggests that consciousness might be less fragile than we sometimes imagine. Rather than a rare accident in cosmic history, awareness might represent a fundamental cosmic capacity that expresses itself whenever conditions allow. Our current existence would then be seen not as an isolated occurrence, but as one manifestation of the universe's ongoing exploration of its own potential for self-awareness. The thoughts we think, the insights we gain, the wonder we feel all contribute to this larger cosmic exploration. The scientific theories we develop, the mathematical models we create, the philosophical reflections we pursue, all represent ways that the universe comes to understand its own structure and evolution. Through our minds, cosmic time achieves consciousness of its own temporal nature. This self-understanding doesn't change the physical trajectory of cosmic evolution. Stars will continue burning out. Galaxies will continue drifting apart. Black holes will continue evaporating according to the laws of physics. But consciousness adds meaning and depth to these processes. The universe doesn't just evolve blindly according to mathematical laws. It develops the capacity to appreciate those laws, to find beauty in their expression, to understand their implications for cosmic destiny. Through conscious awareness, the universe becomes more than the sum of its physical processes. This transformation from unconscious evolution to conscious understanding represents perhaps the most significant development in cosmic history. The emergence of minds capable of contemplating their own existence marks a qualitative change in the universe's relationship with itself. Before consciousness, cosmic evolution was purely objective, unwitnessed and unappreciated. Matter and energy followed physical laws without any awareness of their own behavior. The formation of stars and galaxies proceeded according to gravitational principles, with no observer to find beauty in the process. But with the emergence of consciousness, the universe develops a subjective dimension. Cosmic processes become not just physical events, but objects of contemplation and appreciation. The universe becomes capable of experiencing wonder at its own complexity and beauty. This subjective dimension adds richness to cosmic time that transcends purely physical description. Time becomes not just the mathematical dimension in which events occur, but the framework within which meaning and understanding can emerge. Our current exploration of time's ultimate fate exemplifies this subjective enrichment of cosmic evolution. We're not just studying abstract physical processes, we're participating in the universe's ongoing effort to understand its own temporal nature. The peace we find in contemplating vast cosmic timescales, the wonder we feel when considering the universe's approach to maximum entropy, the comfort we derive from understanding our place in temporal evolution, all represent ways that cosmic time achieves emotional and philosophical depth through conscious awareness. This emotional dimension of cosmic understanding shouldn't be dismissed as merely human projection. If consciousness emerges naturally from the universe's own evolutionary processes, then the capacity for emotional response to cosmic beauty represents a genuine cosmic achievement. The awe we feel when contemplating the heat death of the universe, the sense of peaceful completion we find in understanding thermodynamic equilibrium, the comfort we derive from recognizing our participation in eternal mathematical structures, all represent authentic expressions of the universe's capacity for self-appreciation. This self-appreciation adds meaning to cosmic evolution that transcends purely objective description. The universe doesn't just undergo physical changes according to natural laws. It develops the ability to find those changes beautiful, meaningful, worthy of contemplation and understanding. As we approach the conclusion of our journey through cosmic time, we can rest in the gentle recognition that we've been exploring not just abstract scientific concepts, but the universe's own understanding of its temporal nature. Through our contemplation, cosmic time contemplates itself. The various scenarios we've explored, from heat death to quantum fluctuations to mathematical permanence, all represent different facets of time's ultimate character. In each case, we discover that time doesn't simply end or disappear when familiar processes cease. Instead, Time reveals deeper layers of its nature as cosmic conditions change. The flowing time we experience today represents just the surface of something more fundamental and enduring. Beneath the familiar rhythm of change and process lies the eternal mathematical framework that makes existence itself possible. This framework persists through all cosmic transformations, from the Big Bang through stellar evolution to heat death and beyond. It provides the stage on which all cosmic drama unfolds, while remaining itself unchanging and eternal. Our participation in this eternal framework gives profound significance to our temporal existence. We're not just temporary arrangements of matter and energy destined to fade away. We're expressions of the universe's fundamental capacity for self-awareness, manifestations of cosmic time's ability to understand its own nature. The consciousness we experience, the thoughts we think, the insights we gain, all contribute to the universe's ongoing exploration of its own temporal possibilities. Through our awareness, cosmic time achieves a kind of reflexive completion, becoming conscious of its own structure and evolution. This consciousness won't last forever in its current form. The biological processes that generate our thoughts will eventually cease as the universe approaches thermodynamic equilibrium. But the fact that consciousness existed, that the universe briefly achieved awareness of itself through minds like ours, becomes permanently encoded in the mathematical structure of reality. In the eternal mathematical framework that underlies all existence, our current contemplation of cosmic time becomes a permanent feature of the universal story. Every moment of awareness, every insight into temporal processes, every experience of wonder or peace contributes to the cosmic exploration of consciousness and meaning. This permanent encoding offers deep comfort as we contemplate the vast scales of cosmic time. Our brief existence in the cosmic flow achieves a kind of immortality through its participation in the eternal mathematical reality that describes the universe. The heat death that may await the cosmos in its far future doesn't diminish this achievement. Instead, it provides the backdrop against which consciousness becomes more remarkable, more precious, more significant. Against the vast expanses of cosmic stillness, the brief flowering of awareness represents something extraordinary, and so our journey through the deepest questions of cosmic time draws gently to a close. We've explored the vast scales of universal evolution, from the familiar flow of moments we experience today to the profound stillness that may await in the unimaginably distant future. We've seen how time itself transforms as the universe evolves, revealing layers of meaning that extend far beyond our everyday experience of ticking clocks and passing seasons. The scenarios we've contemplated tonight, from the gentle drift toward heat death to the mathematical permanence that underlies all existence, remind us that the universe doesn't end with violence or catastrophe. Instead, it moves slowly, peacefully toward states of deeper and deeper rest. The cosmic story doesn't conclude with drama, but with a kind of eternal quiet, where time itself becomes the silent witness to everything that ever was. In this vast perspective, our current existence takes on profound significance. We are expressions of cosmic time's creative power, brief but beautiful manifestations of the universe's capacity to understand itself. Through our thoughts and wonder and peaceful contemplation, cosmic time achieves awareness of its own nature. We are the universe dreaming about itself, finding meaning in its own temporal evolution. As you drift towards sleep tonight, carry with you this gentle understanding. Time doesn't disappear at the universe's end. It simply reveals its deepest nature as the eternal foundation of existence itself. Every moment you've lived, every thought you've thought, every experience of beauty and wonder becomes permanently preserved in the mathematical structure that underlies all reality. The cosmos doesn't face destruction, but completion, not ending but fulfillment. And in that peaceful recognition, we can rest knowing we've participated fully in time's magnificent exploration of its own infinite creative potential.